Okay. All right, so we're going to talk about some sequences of numbers. Section 6-5, is that what this is? Is that what I just said, or was that what we just did? 6-6. We just did 6-5, okay. Yep, section 6-6. Sequences, okay? There's two different special types of sequences of numbers that we're going to talk about. The first one, and it looks like this is, it's spelled arithmetic, but it's pronounced arithmetic when we're talking about sequences, okay? It's like tomato, tomato. I mean, if you say arithmetic, I'm not going to yell at you, but it's pronounced arithmetic. An arithmetic sequence, an example of an arithmetic sequence is if I give you something like this, 2, 5, 8, 11, 14, and so forth. There's a pattern there, okay?
That's all.
And what is the pattern? What would come after 14? Any guesses?
It's 17.
17. What comes after 17?
20.
20. What's the pattern?
23.
Goes up by 3.
When? Sometimes? Every time. You're adding by 3. Another example of arithmetic would be 100, 96, 92, 88. Anybody know what comes after 88?
80.
Careful, not 8.
Hold on, I gotta get the rhythm. That was wild.
Gotta get
Yeah.
the rhythm.
Yeah, hold on, I gotta
Get the rhythm?
of it.
Okay.
It's
84,
Then what?
and then 80.
What's pattern?
It goes
Minus
down
four.
minus 4.
When?
It goes forward,
Sometimes?
then
All the time.
All the time. Okay. So arithmetic, you're either adding the same thing on every single time, or subtracting something off the same thing every single time. Okay. Arithmetic, you're always adding or subtracting the same number. Now the other one is something called geometric.
We're doing geometric sequences.
Geometric ones, main ones are going to be geometric in this one. So if I gave you a geometric, this is an example of a geometric one. 2, 10, 50, 250. Now, what is the pattern here? Am I adding the same number every time?
No.
No, if I was adding the same number, how would I go from 2 to 10? I would have added what? No, what would I add if I went from 2 to 10?
Well, 8.
No.
8. So the next number should have been what if I was adding 8?
8.
I can't
Like it should have
No,
been.
it should have been 18.
Should have been 18. It's not. So I'm not adding the same thing, but there is a pattern. How else can I go from 2 to 10? Instead of adding
Times by 5.
and then times by 5. So how do I get the next number?
Multiply
Times by 5.
Times what by 5?
250.
250, and it's 1250 and so forth, okay? You don't expect to necessarily do that in your head, but hopefully you see a pattern, okay? So, or another example of geometric, if I gave you something like this. 80, 40, 20, 10.
Subtracting.
Careful.
Each time.
Am I subtracting? If I'm
No,
subtracting,
no.
well, hang on, let's go subtracting. How would I subtract and go from 80 to 40?
Well, you're dividing.
That's not what I asked. If you're subtracting, let's stick with your first answer, okay? And you're right, but let's go with your first answer. If I was subtracting, how would you go from 80 to 40?
40.
What about 40?
Minus
So the next number should have been what?
8.
0.
Yeah.
And it's not, it's 20. So what's another way of going from 80 to 40?
Dividing.
By
2.
2. So what comes after 10?
5.
5, and then 2.5, and so forth, okay? So geometric, you're either multiplying or dividing by the same number every time. Arithmetic, you're adding or subtracting. Geometric, you're multiplying or dividing, okay? That's what you need to get. Okay, now I want to make sure you understand. Just because there's a pattern doesn't mean it's arithmetic or geometric. Like if I give you this, I'll see if you guys can come up with this one. If I gave you 1, 3, 4, 6, 7, 9, 10, 12, 13. Just curious, right? Let's see. Anybody know what comes next? There's definitely a pattern there.
Wait, wouldn't it be 15?
Then what?
16.
15, 16, then what?
17.
No?
18. Oh, 18.
18?
19, 20.
What's the pattern?
It goes up by 2 and then up 1.
Right. Up 2, up 1, up 2, up 1, up 2, up 1, and so forth, okay? So, is there a pattern?
Yes, there's
Yes.
no
Is it
change.
arithmetic though?
No.
No, because it has to go up by the same number how often? Every time, okay? Here it's flip-flopping, okay? It's going up 2, then it goes up 1, then it goes up 2, then it goes up 1, okay? So in that case, it wouldn't be arithmetic or geometric. So just because there's a pattern doesn't mean it's arithmetic or geometric. It might not be either one, okay? All right, we're going to dive into the assignment, okay? So that's mainly it right there. There's a few things we still need to talk about, and we'll do that when we get to it. So let's look at, now one thing also, I want to point something out to you, okay? And some of you are doing pretty good at calculating in your head, and good. Some of these are going to get a little bit more complicated, okay? I want to show you something, okay? If you didn't see that, and I'm not making fun here, okay? I'm not making fun. But if you didn't see that you're timesing by 5, if you didn't see that, and there's going to be some problems that everybody here, you're going to look at and go, oh man, I can't figure this out in my head at first. You got to know how to figure it out in your head. I'll show you how, okay? If you didn't know it was timesing by 5, here's what you can do.
You can put the arrow down and put a number.
Well, just take any number and divide by the one in front of it. What's 10 divided by 2? 5. What's 50 divided by 10? 5. You know what 1250 divided by 250 is?
No. 5.
It's 5. It's 5. If you take, it'll be the same thing every time. Same thing here. Take 40 divided by 80. What's 40? What goes into 40 and 80?
2.
Bigger.
Oh.
2 does. Something bigger that goes into 40 and 80? Bigger than 10. 20 does. Something bigger than 20 though. 40 goes in here how many times? Once and
then twice.
so I want to make sure you understand what is a half. That is what we're timesing by every time, okay? If you're not sure what the pattern is, take any number and divide by the one in front of it, okay? You know what 10 divided by 20 is? A half. 20 divided by 40? A half. 40 divided by 80 is a half. That's what you're timesing by, a half. You're taking half of it every single time, okay? All right, so let's look at exercise number 3. These start out really, really quick and simple, okay? So they want 4, 12, 36, 108. 4, 12. Now again, some of you are going to look at this and you're going to know some of you already know the answer. And if you know the answer, great. But I'm interested in how to get the answer. What they're asking for is, what is the common ratio? The ratio is what are you timesing by? What is it we're timesing by? 4, then 12, then 36, and 108. 3. Now, if you didn't see that, the answer is 3. This problem's done. The common ratio is 3. If you didn't see that, here's what you could have done. Take any number, almost any number. The only number you can't take is 4. Here's why. Because you take any number and divide by what's in front of it. Why can't I pick 4? There's no number in front of it. Start with 12. Take 12 and divide by 4. You know what you get?
3.
You know what 36 divided by 12 is?
3.
That divided by that?
3.
3. Do you have to do it on every one of them? No. Just do it on one of them. Okay? So that's all they want. What's the common ratio? So what is so special? What's so special about 3? What's so significant about the number 3 on this problem?
It's all going up by 3.
What do you mean going up by 3? You're adding 3?
Going up by 3 times.
Multiplying by 3. So what you're multiplying by? You're multiplying by 3. Okay, let's look at number 5. Okay, 3 eighths, negative 3. 3 eighths, negative 3, 24, negative 72. I think that's what it says. Nope, negative 192. 24, negative 192. Okay, so what is, and this is a little bit different because it goes from positive to negative, okay? Here they're all positive, okay? When they flip-flop, I'm going to tell you right now, you don't need to memorize this, but it's nice to know. When they flip-flop and go positive, negative, positive, negative, positive, negative, your common ratio is going to be a negative number, okay? If they're all positive, your common ratio is positive. If they're all negative, it's still positive. It's when they flip-flop that your ratio is going to be negative. Now again, you might be looking at this going, I don't know what this is. So take any number and divide by the one in front of it. Now I could take this and divide by that.
But it would be hard.
Why?
Because there's a fraction.
So don't do that one. I could do this divided by this, but that's a big number. So you know what I'm going to pick?
24 and 3. Negative.
And do what with 24 and negative 3? 24
24 divided by negative 3.
is negative 8. Okay? So what is so special about negative 8?
That's what it's.
That's
The
the
pattern.
difference or the ratio.
Pattern how? The ratio, which means what? It's the number that we're doing what?
Finding out, I don't know.
Okay. How would I find the number after negative 192?
Times by negative 8.
That's the number you're timesing by. You just answered it. It's what you're timesing by. That tells you what you're timesing by. You're timesing by negative 8. Okay? What's so special about 3? To get the next number, we take 108 and times by 3. It tells you what you're timesing by. 7. 19. Okay, this is another one. This is a tougher one. This is one that most of you, when I first look at it, I don't know the answer. I'm going to have to do a little calculating in my head, and even that's going to be kind of tough. 128, 96, 72, 72 and 54. Okay. Okay, so what is it that they're timesing by? I don't know. So take any number and divide by the one in front of it. I could take 96 divided by 120. It doesn't matter which one. Alana already answered this on the last one. Why, I could have done this divided by this. Why didn't I?
Because it's a fraction.
Well, I
and
like
it's
fractions,
more
okay?
difficult.
And I didn't do these because that's a big number, okay? So which ones would you guys like to pick?
72 and 96.
Yeah, I'd do something else though. I'd probably do
54 and
54
Why?
and 72, because they're
Because
smaller
it's
numbers.
small.
smaller, easier to work. Is it wrong to do 72 and 96?
No.
No, but it's easier to use small numbers. I'm gonna take 54 and divide by 72, okay? Now that simplifies. What definitely goes into both of those numbers? What goes into 54 that also goes into 72?
50.
Not evenly. What evenly goes into 54 and 72?
Oh wait, isn't it like
Think you want them.
I don't know.
Did I talk to you guys about 3 the other day? If 3 goes into a number? How do you tell if 3 goes into a number? Add up your digits. What's 5 plus 4?
9.
Does 3 go into 9?
yeah.
So 3 goes into that. Does 3 go into 72? Add them up. What's 7 plus 2?
Yeah.
So 3 definitely goes into both those. I'll be your calculator. You divide this by 3, you get 18. You divide that by 3, you get 24. What goes into 18 and 24? That simplifies even further.
2,
How do you know 2 goes into it?
because they're both even.
You could have said that back here, okay? 2 does. There's actually something bigger though. There's nothing wrong with 2. There's nothing wrong with 2. Is there something
4.
big?
8, I don't know.
6 does. 6 goes in how many times?
Like 2.
2.
No, 3.
3?
Oops.
And then 4.
So, how would I find the next number? We're not going to find it, but how would I find the number after 54? I would take
Oh, times.
by what?
3/4.
3/4. And it makes sense that the numbers are getting, if you times by 1, nothing happens. If you times by a number smaller than 1, it's going to get smaller. And these numbers are getting
Bigger. Or smaller.
smaller, okay? They're getting smaller. Okay, number 9. All right, what's number 9 say? Okay. All I want is, okay, they give they want to know, is this arithmetic or geometric or neither, okay? Remember, arithmetic, you keep adding the same thing every time or subtracting the same thing every time. Geometric,
Yeah, it is. It's the first one.
why?
Because it's increasing by the same amount.
Which is what?
But it's
8.
8.
Going up by 8 every time, okay? So this is arithmetic. And filling in the blanks because it has a common difference of positive 8 or negative 8.
Or positive.
How come?
Because it's increasing.
It's increasing, okay? So you're filling in the blanks. It's arithmetic, so it's going up by 8. Okay? Let's look at number 11. Same question. Different numbers, though, okay? 9, 14, 20, 27. Okay. Is it arithmetic? Is it going up by the same thing every time? How do you go from 9 to 14?
No, it's not going.
5.
5 and then 7, so it could be arithmetic.
It could or couldn't?
It couldn't.
It couldn't because it went up 5, then it went up what?
It went up 7, I think.
And 6. And then it went up 7. Okay, so it's not arithmetic. Is it geometric? Well, let's check. If I take 14 divided by 9, take any number and divide by the one in front of you. You do that, you use a calculator, you're going to get 1.5 repeating. If I take 20 divided by 14, you get 1 point, what do you get? 6, 4, 2, 3, 7, 4, 2. So is it geometric?
No,
Why?
because it's not.
Yeah, why? It's not geometric. Why?
When you're dividing the one in front of it, it's not the same.
Yeah, these numbers should have been the same. They're close. Close isn't good enough. They got to be the same, okay? So what do we put? Is it arithmetic or geometric?
It's not.
Nothing.
Neither. Now, there actually is a pattern. Anybody know what would have came after 27?
Yeah, 8. Oh, you mean the next number.
The next number. What would I know what you mean?
The next number would be 35.
35, then what?
Then 44.
What's the pattern?
It goes up by 1.
Well, from nine,
It's
went up
plus
what?
5, then it's plus 6 because the number that it's going up by is
One more each time. So went up 5, then went up what?
Sixth,
then seventh, then eighth, and so
ninth.
is there a pattern?
Yes.
But it's not arithmetic or geometric, it's neither one. Okay, it's neither, and what do we fill in the blanks here with? There's no common difference, and there's no common ratio. It's neither one, okay? If there was a common difference, it'd be arithmetic. If there's a common ratio, it'd be geometric. There's neither one, okay? Okay, 13. Okay, just a few more and then we'll stop for today. Number 11, so number 13. Okay, same thing here. Is it arithmetic or is it geometric or neither? Okay, so they give us a number 13. 192, 24, 3. And then 3/8, okay? First off, is it arithmetic?
No.
There's no way it's arithmetic because think about it.
24.
If it went from 192 down to 24, it subtracted off a ton. Then it went, you didn't have to do the math. If you went down from 24 to 3, it went down the same amount?
No.
Not even close. Went down about 20, 21, okay? It's definitely not arithmetic, okay? Is it geometric? Let's check. Let's take any number and divide by the one in front of it. Let's take 20. Okay, 3 and 24.
That would be 6.
3 goes in
5,
here once. 3 goes in here 8 times. Now let's do this. Let's take 24 and divide by 192. I will tell you this. 24 does go into both these. 24 goes in here once. 24 goes in here 8 times. Is it geometric?
Yes.
Why?
Because they're the same.
Back here, they weren't the same. Here, it is the same. What's the common ratio?
1/8.
1/8. So it's geometric. Common ratio is 1/8. Oh, hang on a second. And it's a common ratio of 1/8. Not difference. Ratio means is what you're timesing by. All right. Okay, these next ones look a little weird. They give you graphs, okay? I'm going to put the points on the board here. I'm not going to put the graph. Here's what the point, they have the points labeled for you. They have the point 1, 2, 350. Oh, wait a minute, that might not be the next one. I left off 210. I'm sorry, 210, then 350. And then 4, 250, and that might be it. 4, 250. Okay, so don't get thrown by this, okay? Think of it as the first value is 2, the second value is 10, the third value is 50, the fourth value is 250. So really all you need to look at are the y values, okay? I went from 2 to 10 to 50 to 250.
Isn't it multiplied by like 10?
Multiplying by what?
Not 50, but yeah, 10. Isn't it 10?
Well,
No, it's not
if you
10.
times by 10, you'd be at 20. What are you timesing by? How do you go from 2 to 10? Times by 5. How do you go from 10 to 50? 50 to 2, 5. So, arithmetic or geometric? Because we're doing what? Multiplying.
No, it's not. Wait, isn't that one? Yeah.
Yeah. Arithmetic, you're arithmetic starts with an A, adding. Okay. Geometric doesn't start with an M, but as long as you know arithmetic's adding, geometric is you have a ratio of 5. Geometrics, you have a common ratio of 5. Okay, how many more do I want to do here? 17, 19. No more than 4 more. We'll see how long these take. 17. Okay, so again, they give you a picture. You don't need to have the picture. I'm just going to give you the dots. And what really matters are the y values. I'll put them down there. 1, 120, 2, 60, 3, 30, and 4, 15. Okay. Whoops, 4, 5, not 4, 15. Wait, hang on a second. 60, 20. Oh, no, okay. 1, 120, 260, 330. No, 320. 320, 4, 5. Okay. So first off, is it arithmetic? Is it arithmetic? How would you go from 120 to 60 if it was arithmetic? Subtract what? How much? How do you go from 12 to 6?
Subtract 6.
Let's put a 0 on it.
6.
So subtract 60. So what should the next number be? Subtract 60, it should have been what?
0.
And it's not. Okay, so it's not arithmetic. Is it geometric? How do you go from 120 to 60?
Yes, it is.
Divide it in 2. So divide this in 2, what should the next number be?
30.
Is it?
Direct 30.
So which is it? Arithmetic or geometric?
Neither.
It's neither. It's neither because there's not a common difference or ratio. Has neither one. Okay, number 19. They want the next three terms, 5, 20, 80. They want the next three terms, okay? They want the next three terms. So, what's the pattern? How do you go from 5 to 20, then 20 to 80, then 80 to 320? Multiply. Now, if you didn't know that, how could I figure out the number? Where's the number 4 come from? I could have taken 20 and did what with it? Divide by 5, and you get 4.
Giving it to you.
80 divided by 20 is 4. So, how do I find what times 4? So, how do I find the next three numbers? That's what they're asking. How do I find the next three?
320
320
times 4.
times 4. If I take 320 times 4,
No, you're-
64, 1280. How do I get the next number?
Multiply that by 4.
Multiply that by 4, I'm going to cheat. 5120. How do I find the next one? Multiply that by 4, and you get 2480. Okay? They also ask you to graph them. When you're doing these, if you need help graphing them, I'll show you how to do it, okay? Okay, 21. Let's see. I think we'll stop there.
Yeah.
Okay, we'll stop there. Okay, and again, you're going to need to graph those on number 19. If you need help, just ask me and I'll show you, okay? Okay, the rest of the time's yours, guys.